Hello, calculus fans. Okay, so let's try another problem. This time we're going to find all local extrema of f of x equals 12x to the fifth minus 15x to the fourth minus 160x cubed plus 360x squared plus 45. Whew, what a function. Now what I hope is that you recognize that this is the same function that we used earlier. We were illustrating the increasing-decreasing test. So we've done a lot of work already with this function. For instance, we've calculated the derivative, but not only have we calculated the derivative, but we did a lot of work to write it in its fully factored form, like this. We also wrote down a sign chart for the derivative. So if you remember, our sign chart looked something like this. So what we're going to do now is classify our critical numbers. Now when I say that we're going to classify the critical numbers, what we mean is that we're going to try to determine whether our critical numbers are local maxima, local minima, or possibly neither. And what we're going to do is use the first derivative test. So for example, at x equals -3, what we can see is that the function is changing from increasing to decreasing, and so that makes -3 a local maximum. If you go up and then you go down, then you have to have a local maximum. At x is equal to 0, we can see it's going the other way around. It's going from decreasing to increasing. So it's going down and then it's going up. So that makes x equals 0 a local minimum. And finally, we can see what happens at x equals 2. It's not changing. It's staying increasing and still increasing afterwards. And so what that tells us is that it falls under the third case of the first derivative test. There is no local extremum at x is equal to 2. Okay, that's all for now.